So then today topic then classical statics from Maxwell-Boltzmann distribution. So from question number 1, the Maxwell-Boltzmann statics is applicable to the particle which are, so then Maxwell-Boltzmann, it's only applicable for distinguishable and non-interacting. Okay, so option B is correct. Then question number 2, then according to Maxwell-Boltzmann distribution, the number of particle having energy E is proportional to, the correct option, the energy is proportional to then e power minus E by then kT. So option B is correct. Okay, the Maxwell speed of distribution curve depends mainly on the Maxwell speed distribution. Which one is correct? Then based upon temperature. So option C is correct. So the Maxwell speed the distribution curve depends mainly on temperature. Okay, so if you draw the curve like this, then we have to get the curve like this. So in these cases that should be we have to get maximum. Okay, so if you get high temperature curve border. Okay, so we have to draw the speed which is number of molecules. Okay, so this is the curve, so it depends only on temperature. Okay, so we have to get high temperature curve border. So question number 4, the most probable speed of a gas molecule. So the most probable, how to write the most probable velocity can be written as then root of 2 kT by m. Okay, where k is the Boltzmann constant, T is the absolute temperature, then m is the mass of a gas molecules. Upon the most probable now, that should be maximum number of molecules. So then speed possessed by maximum number of molecules. So the correct option C is correct. Okay, for an ideal gas, that should be a root mean square speed, that is VRMS, that should be a root mean square speed. So the correct option, how to write, then root mean square root of then 3 kT by m. Here k represent Boltzmann constant, T is the absolute temperature, then m is mass. Which one is correct? The option C is correct. Okay, so then calculate the most probable speed, that is most probable speed of oxygen molecule temperature, that is then given mass, then given Boltzmann constant. Then we know the formula here the formula for root means square. Okay, we know the formula. Okay, then VRMS. So what is the formula for most probable speed? Here 2 kT by m. Here this one is the most probable speed, this one is a root mean square, then we have to take this one. Okay, so the question must be asked, calculate the most probable speed, then we have to take this one. Okay, so first we have to calculate 2 kT. Okay, then 2 into, then k is the Boltzmann constant, already given that, then 1.38 into 10 power minus 28 into temperature given 300. So then what is the final after we have to multiplying, that is we have to multiply everything, we have to get 8.28 into 10 power minus 21. So from that we have to just divide by m. Just then what is the value for m is given. Okay, that is 5.31 into 10 power minus 26 then we have to divide, then we have to get this one is 1.539 into 10 power 5. So just we have to take square root, then root kt by m into root of 1.539 into 10 power 5. So finally we have to get the most probable speed is approximately 395 meter per second. Which one is correct? Option B is correct. Okay, so this is the most important formula I have to remember. So first we have to calculate 2 kT from 2 kT, then after that we have to divide by mass is given, then after that we have to take square root, we have to get the final answer. Okay, so next question, then find the RMS, that should be a root mean square speed. Root mean square speed of the nitrogen, then temperature T kududachi, then mass kududachi, then K. Then what is the formula for root mean square? So already we have to given that. Here root mean square speed is this one, then root of 3 kT by m. But just we have to put that, then root mean square speed 3 kT by m. Okay, so just we have to take straight away, then 3 into what is the K? K is 1.38 into 10 power minus 23 into temperature T is equal to 300, then divide by what is the mass, then 4.65 into 10 power minus 26. So finally you have to get this V root means speed approximately 517 meter per second. Okay, then we can calculate direct, otherwise we have to first calculate 3 kT, and after that we have to divide by m, then after that we have to take square root. Okay, or we have to put straight away. So the correct option is B is correct option. Okay, these are all the simple problem. Just we have to know the formula, just we have to substitute the given data, then after simple calculation we have to get the result. Okay, so we have to remember two formulas. One is most probable speed, then root 2 kT by m, then root mean square speed root 3 kT by m. We have to remember this, here 2, here 3. Okay, the next, as the temperature is increases, what is the Maxwell distribution curve became? So as temperature is increases, above what happened? If you see that already we have to draw the curve. So if you increases the temperature, then it goes like this. Okay, from that given option, which one is correct? So border and lower. Okay, so option B is correct. If the temperature is increases, the Maxwell distribution curve became, there should be a broader and lower. Option B is correct. You have to see that. So first you have to broader, or it may be like slightly we have to get lower. Okay, so most important. Okay, so this is one of the most important one. Then order of speed in Maxwell distribution. So what is the correct answer? Then B, most probable, is lesser than average speed, then lesser than root mean square. Which one is correct? The option B is correct. Okay, otherwise sometimes greater like kepanga. Okay, so just we have to reverse it. Okay, just we have to reverse it for some cases based upon the option you have to choose that. Okay, so they are reverse like ekla. Okay, but you don't confuse it. So then Maxwell Boltzmann statics obey which one is? So classical mechanic approximation. Okay, so then remaining we discuss tomorrow. Thank you.